problem are there so that they can be surmounted. With that spirit and methodical approach, we started encountering our problem. Mr. Premanshu Shah will be discussing further.
Actually, the problem is not only due to maintenance, but an operation is also there. But we will be discussing on the maintenance. We have followed the total improvement cycle to encounter such problem, where it has 5 phases. First of all, we gather the data from the problem, then we focus to analyze it. After that, we do the root cause analysis for the solution. Then we implement the solution according to plan, and we try to wasteful for sustaining the benefits. See, here we showing the 7 QC tool we are using in our different problems. First of all, we do the gather the data from there. We segment the data stratification. After stratification, we do the Pareto analysis. From there, we vital few we found. For that problem, we do the brainstorming to get the probable reason for the problem. After the problem we found, we do the root cause analysis. Here we have already shown the problem was in the quality date as well as the availability issue. The quality date we found after the Pareto, the most problem due to the failure of air operated diaphragm pump, where 15 number of failure due to the AOD pump. Then we found for the availability issue, the problem was due to the treating of oxidizer. Almost 810 minutes of failure due to the oxidizer. See, here we are showing the basic principle of AOD pump. AOD pump or air operated diaphragm pump is our heart of our color paint line. It supplies paints or chemical to designated location. See, here we are showing the different part of the system where backup role, applicable role, pickup role also there. See, here we are demonstrating the different components of the AOD pump. After overhauling, we found it. After brainstorming the reason behind the 15 number failure, we found different reasons. The reason behind much failure was in the chemical coater, and few failures in the paint coater also due to cotton insertion inside the pump. We have some problem in the overhauling procedure was not defined also. We have problem the lack of knowledge in overhauling also. Why the chemical coater pump failure? We start analyzing because the problem was not visible. As after the overhauling time, we found no component was getting failure. After brainstorming, we found by our analysis why the back pressure is there. Because in chemical coater, the pump requirement was only 20 LPM approximately, while the pump specification giving 60 to 80 LPM. By means of this throttle valve, we throttling the line, but otherwise it's giving the back pressure to the pump. Due to that, pump was getting stalled. So how to resolve that problem? What we did, we put a parallel line so same as a branch circuit, where same throttle valve used as a branch circuit. By means of this throttle valve, we are arranging maximum of number of chemicals now going back to tank, where remaining 20 LPM going to trade. Now no much back pressure on the pump. By means of that, we completely solve the chemical cotton pump issue. We have another problem in paint coater also, where cotton ingredient inside the pump. How this cotton comes? Cotton comes during the cleaning of paint section. By any mistake, operator put that cotton inside the tank, it goes to the AOD pump. What we did, we in-housely fabricated these suction strainers and put before that suction pump. By means of that, we completely eliminated the AOD pump water injection problem also. We found in quarter 1, the problem was 15 number of failure. But again, the problem comes in quarter 2, but in reduced manner. It was 2. Why this failure again? Because there was some mistake. We have not defined the SOP properly. Now it is time to debunk our problem to solve the issue. So we define the SOP properly and we circulate to the operator how to operate the pump, what the overhauling procedure should be. Again, the problem for in quarter 3 will become 1. The issue was that still problem 1 in SOP because operator was not following the SOP. We discussed together as operation and maintenance what to do and how to do. Then in quarter 4, we found become problem was 0. By each failure was almost 4 metric ton of material as a second material. Now by stopping this, we always say 4 metric ton material, only costing around of loss to the company 1 lakh rupees per failure. We have different issue also for oxidizer tipping also, but we found oxidizer tipping the big problem. Now I would like to request Aditya to analyze this thing.
Well, the next major challenge in the path of availability we were facing was regarding the oxidizer tripping. The oxidizer tripping has been segregated into 2 parts. I'll be discussing about the first part. And you could have seen from the Pareto analysis that we have faced a downtime of 810 minutes due to the oxidizer tripping. Before coming to my case, first of all, I would like to brief you about what exactly an oxidizer does. Oxidizer takes the solvent which is produced during the entire coating process and it burns those solvent. And moreover, during the burning, enormous amount of heat is produced and we effectively use those heat throughout the other processes of the line. And now coming down to my problem, the first case was oxidizer was tripping frequently during the startup. Why it was tripping? We have used two number of flame scanner which where the feedback of the flame scanner in terms of voltage comes to our burner control unit, and that voltage went missing a lot of time. After this methodical approach and lot of brainstorming, we found some very interesting cases that the cable, the signal cable for the voltage feedback was laid along with the high voltage ignition transformer cable, and moreover there were noises and interferences due to the auxiliaries of the oxidizer. Now the entire brainstorming and the analysis boils down to a conclusion that the cable which we have used for the signal cable was a simple armored cable. So the answer lies within the problem itself. The corrective action which we have taken, we have changed that simple armored cable to a shielded cable, and thereby we have completely eliminated the problem of oxidizer tripping during the startup. Now I will request Mr. Chinmay Dubey to come forward and discuss about the second problem.
Thanks, Aditya. Good morning to all of you. My friend just explained you about what exactly the oxidizer does. Now moving on to the second problem we faced with the flame scanner feedback. Coil paint line maximum speed is 100 ampere, but we are not able to run the line with the maximum line speed. Let me first tell you the interlocks. When the flame sensor signal fails, the oxidizer trips, and as soon as the oxidizer trips, it stops the whole process line. Now, when we are running at lower speed, that is 50 to 60 ampere, then there is no problem with the feedback of flame scanner. But as we go for higher speed, that is towards 100 ampere, the oxidizer is started tripping. In the beginning, we are not getting that why the oxidizer is tripping, but by doing some brainstorming and continuous observation of burner control unit and analysis through trends, we came on the result that when the solvent percentage in the oxidizer increases, then only the oxidizer is tripping. Let's understand this problem with the help of the figure. As you see in the figure, solvent fumes are coming from prime and finish oven, and it follows the path which is at back side of the burner. And when the huge amount of solvent comes along this path, it blocks the view of the flame scanner which is at the back side of burner. Because when the huge amount of fumes come here, it blocks the UV radiation emitted from the flames to enter the flame scanner. This is the major problem of the oxidizer tripping. Now we thought that we have two flame sensor. If this sensor is not working, then what about this? When we check the voltage across this flame sensor, we found that it gives only 0 to 2.5 volts, which is a very low feedback. This flame sensor has problem with the initial mounting also. Now let's come to the modification part. What we have done, we have extended the sensing tube of the backside burner flame scanner, so that when the fumes are coming, it didn't block the path of UV rays coming from the flame to the sensor. And the modification that we do in the flame scanner, which is on the side wall, we made it perpendicular to the flame so that it can see the flame in a broad way. As we know that flames, UV rays are emitted more from the root part of the flame, that is around 30 to 40%. That is why we tried to put the flame scanner so close to the root, so that root of the flame, so that we can see more flame. By doing this, we stop the tripping of oxidizer due to the failure of flame scanner. Now coming on to the benefits of the flame scanner, when the oxidizer trips and it restarts, it took around 360 to 400 kg of LPG per hour, and it took 2 hours to reach the temperature, that is 750 degrees temperature. It means it would take around 800 kg of LPG, which is now being saved. Now, due to the cable issue, we lost our 3 flame scanner. Each flame scanner costs around 2 lakh of rupees. And by doing this improvement, we increase the productivity of line, which is our main concern. We increase the productivity of line around 3,600 metric ton per month, which is a very big achievement for us. Now, to explain the overall benefit of the project, I would like to invite Mr. Premanshu to explain.
Thank you, Chinmay. See, we follow the improvement cycle for each and every problem to solve it. But here only due to time lag, we present in major cases for AOD pump failure as well as oxidizer tripping. But for other cases also we follow the same procedure. By means of following these, we achieve the result like shown over there. But these were not only contribution from maintenance, there was contribution from the operation also, as there were issues during some quality issue from operation problem, as well as the downtime from the operation. Thank you for your valuable time. So welcome to all of you for suggestion and questions.
Pump excessive pressure. Take that pump as the isolation. So normally the pressure release is basically a
No sir, this pump is only air operated pump, simple pump. I would like to show again the slide.
It's okay, but then normally there is pressure relief valve for any hydraulic.
No, this is not hydraulic pump. This is only the pump operated by the air pressure,
That's
where
good,
directly only air pressure is there, it's sucking the paint or chemical.
There should be a relief valve always. That's what I am saying. Whatever you have done right now.
The function of reliever
Standard
does not
design.
work over here, because as a hydraulic background I can say the function of, because the solution we took over here as a backup line for hydraulic sense, because such bypass line you cannot see in any type of AOD pump circuit. Okay, so this hydraulic knowledge I put over there to get the solution.